All right, so today we're going to finish up 4.2. Yesterday we did vertex form, and today we're going to do intercept form. All right. I think before we do the intercept form and talk about it, I want to work one example. It's example 2 in your book. It is a reading problem, and it's dealing with civil engineering. So I got any guys in here? I don't mean guys like as boys, okay? I mean guys as in people, all right? So I got any kids in here that are thinking about engineering? All right, lots of math and engineering, right? Okay, civil engineering. Anybody thinking about civil engineering? What is civil engineering? Do y'all know?
Bridges,
big
stuff,
roads,
construction of big stuff.
all the little mix master things that you go through when you go to Houston, you know, and try to get somewhere. When I approach one, my heart rate goes up. It's just like you're taking a test. That's what happens to me when I approach one of those mix masters. I'm like, oh, please help me get on the right one. So, but that's what civil engineering is about, all right? So this is about a bridge, this problem is, and it's a really easy problem.
Yay.
It's a problem that if it were on a worksheet, 1/2 of you guys would go, nah, not gonna do it, it's a word problem. Okay? But I wanna show you how easy it's gonna be. So watch this. The Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by suspension cables as shown. So we have a suspension bridge. Do you agree? All right. So we got a tower over here. Okay? And we got a tower over here. We have a lot of suspension bridges around here. Do you agree? Here's my road right here. The towers are connected by a cable. I didn't know what it was called, but the kids told me second period. It's Memorial Bridge. Remember? Memorial Bridge right outside of Bridge City. On the other side of Bridge City is a suspension bridge. And then this cable that connects the towers is connected to the road like this. Do you agree? Everybody know what I'm talking about? Is this drawn to scale?
No.
No, I don't know, y'all. No, it's not drawn to scale. I just sketched a picture of it. Okay? It did tell me this. It did tell me that the towers were 307 feet tall. So I am going to mark that on my picture. Okay? And it also says this. The cable can be modeled by this function. So it's giving me a model, a function that models this cable. What does it look like it's making? What is that called? A parabola. Okay? A parabola. And here's the equation. Y is equal to, now this is real life. Is this going to be a pretty equation?
No.
No, it's not. Okay? So 1 over 7,000. Now, first of all, what does that tell you about it? He's opening up. And what about this? What is he? Wider. Lots wider, right? 1 over 7,000 is a lot smaller than 1. Okay? So it's a lot wider. 1 over 7,000, open parentheses, x minus 1,400 quantity squared plus 27. So you understand why we should have done this problem yesterday, but we didn't. All right? So it's in vertex form. Do you agree? Okay? And here's what they want to know. They want to know how far apart are these towers? How far apart are these towers? Okay, so what if we pretend, all right, what if we pretend that this is my y-axis and this is my x-axis? Okay? Do you know the vertex of this parabola right here? Do you know the vertex of this parabola right here? Yes? What is it? We did this yesterday too. Come on. Thank you very much. It's screaming at you in the problem. Change the sign and keep the sign. Change the sign and keep the sign. Okay? So it's 1,427. All right? Now, does that sound reasonable? Here's what that's saying. It's saying from here to here is how long? From here to here is how far? 1,400. Is that reasonable? Okay. And from here to here is 27. Is that reasonable? Yeah, that's reasonable. We've seen bridges like that. Okay. So how would you find the distance all the way across? Do what?
1,400 times
That's it.
Wow.
2. That was way too.
So there you go. Was that hard?
No.
People, that was like the easiest giveaway. That's a present in a box. Okay? That's just a present in a box. Okay.
Why are we times about 2?
Because 1,400 only goes,
Halfway.
yeah, 1,400 is from here to here. And the vertex is where in our parabola? Right in the middle. So if this side right here is 1,400, then this side right here has to be 1,400. Okay? So the distance between the tower will be 28. Anybody got a question? Okay. So now we're going to do the intercept form. This was the vertex form. Remember, A times x minus h quantity squared plus k. So where we got our hk for our vertex. Okay, so now we're going to do the intercept form. This is your paper from yesterday. 4.2, graphing quadratics and vertex and intercept form. We're going to write it up here because I want you to look at it all together. Okay? I want you to go, oh, these are the 3 forms that we're going to graph them in. Standard form, vertex form, and intercept form. Okay? All right. Everybody okay? Okay, so here is intercept form. Y is equal to A. Guess what, people? That A is the same A as this A and this A. What is A going to tell me?
If it's up or down.
Okay, the sign will tell me if he opens up or down, positive being up, negative being down. Very good. And the absolute value of this number, okay, is going to tell me if he's wider, narrower, or the same. If the absolute value of this number is greater than 1, he's narrower. That's a vertical stretch. If it's between 0 and 1, he's wider. That's what happened over here with our bridge problem. All right? 1 over 7,000 is definitely not greater than 1. Okay? He is between 0 and 1, so that's why this cable swings really wide. Okay? So A times x minus p times x minus q. All right, so that's my intercept form. Now, watch this. Obviously, if it's intercept form, guess what I can look at it and shout out? The X-Intercepts. Okay, the X-Intercepts. And they are P and Q. P and Q. Notice what's happening. You always need to notice what happened. From here to here and here to here. What happened to them?
They changed signs.
They changed signs. Does that make sense to you that they changed signs? Who are they with?
The X.
They're with the X's, people. They're doing the opposite. They're weird. Okay? Here's another way to look at it as far as changing signs. I could just take this factor and set it equal to 0, and then when you solve for x, do you see that you would do the opposite to get the x by itself? For instance, if it was x plus 2, then you would pull that 2 to the other side, minus 2, or you'd subtract 2 for both sides, and x would be negative 2. If it was x minus 5, you would add 5 to both sides, and x would be positive 5. Okay, so that's just another way to look at it. All right, so the next thing we need to find, I know the x-intercepts, they're pretty easy. They're screaming at me, okay, is we're going to have to find the vertex, okay? Now this one, obviously, you're not going to be able to just look at it and find the vertex. So like this first one in standard form, you're going to have a little formula. If you understand where the formula comes from, it's a whole lot easier to get it, okay? So what I'm going to do is I'm just going to use a little area right here, and I'm going to draw you a picture and see if you can figure out what the formula is. Because most of you some of you will know it and some of you will come very close to it, all right? So I'm gonna show you a trick to do when you come close and you're not really sure about yourself. All right, so an x-intercept is obviously going to be on the x-axis. Do you agree with me?
Mm-hmm.
Okay, so I'm gonna pretend 1, 2, 3, 4, 5. I'm gonna pretend that I got a parabola and his x-intercepts are 1 and 5. Okay, his x-intercepts. Now, look, I keep some little papers back here. So let me kind of block some of this other mess out because we're not really looking at that and it's very distracting. Okay, so this is really what we're looking at. Are you with me?
Mm-hmm.
Got me a little graph right here. I'm just pretending. Now, where is the vertex going to be with respect to these 2 points?
3.
Right in the middle of them. Do you agree with that?
Mhm.
So do you agree that if I could find the midpoint between these 2 points, that would give me the h coordinate of my vertex?
Mm-hmm.
It has to be in the middle of these 2 because we know it's symmetrical. All right? So how do you find, who knows the formula for a midpoint? Shout it out. What would I do with these 2 numbers?
Subtract them and then divide.
Okay, so do you hear the problem that always happens in people's head? Because some people are saying do what to it? Add them, and some people are saying subtract them. Okay? Now you know once you do that, you're going to divide by 2, right? Because you're going to take half of it. So all you got to do is figure out, am I supposed to add these guys or am I supposed to subtract these guys? Okay, so watch this. I'm just going to show you. What if you get to the test, and even if you know right now, what if you get to the test and you get a tad bit stressed, and then you like go, whoop, I don't know. All right? So here's a trick. Pick something that you do know. Do we know the middle of this guy?
Mm-hmm.
Yes.
Okay. Do you agree that this is the middle?
Mm-hmm.
What is that number?
3.
3. How do I get a 3? What do I do to these 2? And then
Add them
divide by
by
2.
2.
Do you see what I'm doing? I'm like going, I'm not sure which one it is. All right, so I got to play with some things that I know, and then I can figure it out. Because when I subtract them and get 4 and divide by 2, I don't get 3. Okay? But if I added them and got 6 and divided it by 2, then that's my 3. So what am I supposed to do? Y'all, this is P and Q. So how do I find the H coordinate?
Add and divide by 2.
Perfect. Y'all are so dang smart. All right? So P plus Q divided by 2. Okay? Now, how are you going to find K? Yeah. Plug in H. Okay? Plug in H. And that will give you your K. All right. Anybody got a question? Okay, so this is, y'all, this is that easy. All right? This is that easy. So let's do a problem. Are you ready? I'm going to do it right here. No, I'm not. I'm going to do it. I was like, why do I see something under there? I'm going to do it under this problem. Okay, so this is going to be example 3. Okay, example 3. And he is going to look like this. Graph y is equal to 2, open parentheses, x plus 3, close parentheses, x minus 1. All right, so I'm going to start off asking you the same questions. I might pop a little different question in there because of the form that it's written in, but that's okay. All right, we are going to graph this, so I'll go ahead and sketch me a little graph over here. And Merry Christmas, guys. You only have to have 3 points when you graph it in intercept form. Now, we know if it's in standard form, how many points did I say you had to graph? 5. We know that if it's in vertex form, how many points do you have to graph?
3. 5.
5 also, okay? But this is intercept form is the only one that I'm going to let you do 3 points. When we do it, you'll understand why. The majority of the time, it's going to give you a really good shape for your parabola, and you won't need any other points. Okay? So let's answer some questions. Are you ready? When I ask the question, I want you to write your answer down, and that will give everybody time to think about it, and then I'll ask you to call your answer out. So my first question is the direction that this parabola opens. The direction that the parabola opens. Write your answer down. Tell me what you said.
Up.
Very good. This A out here is positive, so that makes my parabola open up. If the A is negative, it opens down. Is everybody okay? All right, my next question, write your answer down. Is it wider, narrower, or the same as the parent function? Is it wider, narrower, or the same as the parent function? What did you write down?
Narrower.
Very good. And the reason you wrote narrower down is what? Very good. The absolute value of this number is greater than 1. Okay? Now y'all look, this number is the coefficient of the quadratic. If you multiply, y'all, if you fold those things out, x times x is x squared. When you multiply it by that 2, it's going to be 2x squared. You see? He is the coefficient of the quadratic. You would have to distribute him through some other stuff too, but he still is the coefficient of the quadratic. All right, so my next question, this one's a little bit different, okay? But y'all, please, it is screaming in your face. What are my x-intercepts? Write them down. Don't say it. Write them down. X-intercepts. Remember what we wrote in pink beside those two things. Okay, what is it?
3, negative 1. -3.
Yes. -3 and +1. What did we write in pink that I said was important?
Change this
You've
sign.
got to change that sign. Y'all, he's with an X. He's doing the opposite. He's weird. Okay? Here's another way to look at it. What was the only thing that we could replace Y with? 0. Okay? So if you replace this with a 0, remember when you factored quadratics in Algebra 1, what did you do to solve them? You set each factor equal to 0 and solve for x. So if I set this factor, x plus 3 equal to 0, subtract 3 from both sides. There he is. X is -3. Look, why would I replace y with 0? Because guys, if you want an x-intercept, you better be laying on that x-axis. What is y? 0. See? It's all just a big old circle of life. Pretty cool. All right, so let's go ahead and plot these. -3, 1, 2, 3, and +1. Okay, so now I'm going to warn you about something because this is what some kids like to do. Some kids go, I don't really need that formula that Miss Davis told us to learn to find the vertex because I can count. People, can I put numbers in there that you will not be able to count?
Yes.
Oh, yes, I can. You better learn the formula and learn how to use it with the nice, pretty numbers so when the numbers get messy, you'll still know how to do it. Okay? So, the next thing I want us to do is we're going to find the vertex. All right? So, what is the formula for the h value of the vertex? Notice what I'm doing. I'm writing the formula down every time I use it until I got it stuck in my brain. Okay? What's my formula?
P plus Q divided by
P
2.
plus Q divided by 2. All right, so what is P? It doesn't matter which one is which, guys. Okay? It doesn't matter which one you call what. P and Q, order, not a big deal. Do I want to put parentheses around this? You know, because then it looks like a point, right? And it's not. It's two x values. All right? So let's say P is -3 plus Q is 1. Okay? So now let me ask you this question. What if you didn't change the signs right here? What's going to happen right here? You're going to get it wrong. Okay? If you miss your x-intercepts, you're going to miss your vertex. You're going to miss your axis of symmetry. You're going to be, that's right, you're going to be in a bind. You'll get up and narrower. Boom. That'll be all you get. All right, so here we go. What's -3 plus 1? And -2 over 2? -1. So my x value is -1. Are you with me? Okay, now what do? I need k, obviously. Plug it in, people. Go up here to this original equation. K is y, all right? So I'm going to find the y value when I plug this x value in. All right, so k is equal to 2 times open parentheses x. Oh, it's -1. Plus 3, close the parentheses, open, x again, -1. Okay, so what's -1 plus 3?
2.
2. What's -1 minus 1?
-2.
-2. What am I doing with all three of these numbers?
Times them.
I'm multiplying them. I only have one negative sign, so what do I know about my answer?
Negative.
He's negative. If you have an odd number of negative signs, your answer will be negative. If you have an even number of negative signs, your answer will be positive. We talked about that skill in Kramer's rule when we were multiplying a bunch of numbers. So 2 times 2 is 4, times 2 is 8. So K is negative 8. So my vertex is negative 1. Negative 1, negative 8. Now, look at that beautiful parabola. Do I have a good idea of what kind of shape he's in? Yes, I do. That's my answer. Oh, what if I asked you for the axis of symmetry?
You know the
That's gonna be negative 1.
Yeah.
Or do what? X equals negative 1. X equals negative 1. Don't forget to write it as a line, guys. It's not a number, it's a line. Is everybody okay? Okay, so was it in this class the other day that y'all were asking me, when are we ever going to use it? Oh, it was. I remember who it was. Started that big conversation, right? He's ignoring me. All right, so I'm going to show you when you can use this in real life. Yeah. All right, so I'm going to show you when you can use this in real life, okay? So here we go, example 4. This is a reading problem. Obviously, if it's a real life application problem. Here's what it says. The path of a place-kicked football. What's a place-kicked football?
It's
Football doesn't get
stationary.
kicked to a certain place.
What?
It's stationary.
It's stationary. Robbie, what's a place-kicked football?
Oh my
There's a
God.
kicker.
You didn't know? I thought you were a kicker.
He's the kicker.
It was the other guy.
Okay, so that's one that's on a tee, right? Is it different from a punt? Yes, it is. Okay, a punt's in your hand, and then you're holding it out and kicking it, right? And a place kick's sitting there on the tee. You're running towards it. Pow, you kick it, right? Everybody got it? So the path of a place kicked football can be modeled by this function. Y is equal to negative 0.0. Thank you, babe. Negative 0.026 x, open parentheses, x minus 46. Are you with me?
Sure.
Yes? Everybody good?
Sure.
Okay. So, let's see what else it says. Where x is the horizontal distance, x is the horizontal distance, and it's in yards, okay? And y is the vertical, or the height, distance, and it's also in yards. All right, so everybody with me? Yes? Everybody okay? Here's my 2 questions. A, how far is it kicked? And B, what is its maximum height? Okay, how far is it kicked and what is its maximum height? Okay, so since this is a real life problem, we're going to do it on our calculator. Okay, so I'm going to go in here and clear out some stuff before. I think I'll leave that in there. Okay, so here we go. Now, here was the first question that I got last period. Is this an intercept form?
Not any form we worked so far.
Wait, is it in? It's not.
Standard form.
Do you see any x squared plus bx plus c?
I don't know. I
No.
guess.
I think it is.
Okay.
The one thing else
It looks
about
like a vertex
intercepts,
form
but
without a
it's
K.
not even really
So
something
K could be
intercept.
0.
Does it? Is it?
When you do the math, it's vertex form.
Okay, tell me why it's not vertex form.
Because it's not square. You don't have a.
It doesn't have a squared, and look what else it has out here.
X
Yeah,
times
it's
X is
got an
X squared.
X stuck on that A. Okay, so let me write this 2 different ways, and then you tell me if you see what I'm talking about. Okay, I'm trying to find a color that I want
Wait.
to differentiate from this
What's the
problem.
one that's like?
Okay, so what if I wrote it like this? Does this change the problem?
Yes.
Yeah.
What?
No, it doesn't.
People, that doesn't change the problem. It's 0.026 times x, that's what this is, times this. Okay? All I did was stick a little pair of parentheses in here to kind of separate that x out. So this is the same thing. It's intercept form. If you needed it to go even farther, could I write it like this? Is this the same as this?
Yes.
Yes, because what is x minus 0? It's x. And there's my x. So it is an intercept form. It's just a little bit tricky because it's all just like slapped out there for you, okay? And you have to kind of go, whoa, wait a minute. All right? So let's put this in. I'm going to go, here's my calculator, okay? I'm going to go to y equals, and I'm going to plug this in, okay? Now before I graph it, I'm going to go and talk about my windows, okay? So I'm going to talk about, and some of you are going to know, and some of you are not going to know. I mean, I like to watch football, but I've never played before, okay? I didn't play, they have intramural football for girls in college and stuff, but I played one day and then I was like, no, I don't like people just like smacking into me for no reason. That makes me angry. So I said, I'm not playing that. All right? So I'm going to go here. Now remember what x is. X is the horizontal distance that the football is going to go. So your place kicking a football, what is the minimum distance it would travel?
0.
0. That would be if you swung and missed, right? Okay? And then, what is the maximum? What do you think the maximum distance that a place kick football might go?
50.
The longest is 60.
A bit.
Is what?
The longest is 63.
The longest is 63. So if we said 60, we would be okay. Do you agree with that? I mean, because it's probably not going to be the longest, all right? So let's go 60. And I'm going to go on, what do you want to go on a scale of?
5.
Yeah, I like 5. We like to try and hang around 10. So I would be okay if you went by 10s, okay, or by 6s, but I like 5. He's kind of right there in the middle. All right, so y is the vertical distance or the height of this football, okay? So the minimum height would obviously be
0.
0. That would be a whiff in golf where you whip the ball and you didn't touch it, okay? In football, I don't know what they call it. Bad is one thing they would call it. But anyway, what do you think that the maximum height this football? Now y'all look at this. Look at this number right here. Is this a really small number?
Yes.
Is this reasonable? Look at this. What's this negative saying about my parabola? Is opening down. Is that reasonable for me kicking a ball?
No.
Yeah. Look, y'all. Look. You're going to kick a ball and it's going to go like, yeah, it's going to go up here and come down like this. Okay? So yes. And it's a really small number because really I'm trying to get a lot of length out of it and not a lot of height. Okay? So what do you think the maximum height might be?
30.
30? Okay, so this morning the kids were saying 10s and 15s and 30s. 10s, 15s, and 30s. So what number did I pick?
15.
30.
30.
Right in the middle.
25.
20. I just picked 20. I have no earthly idea, okay? First of all, I'm not a good judge of distances. So even if someone came and said, how far away were you when you shot that deer? I'd be like, I don't know. I have no earthly idea. Okay? I'm not shooting a deer anyway because I don't like shooting deer. But whatever. So I'm going to say 20 and I'm going to go on a scale of 2. Okay? So I'm going to graph it and hope. Y'all, if it's not good, I go back and change the number. It's not a big deal. It's beautiful. Okay? It's beautiful. Okay, so let's listen to this. Listen to this. Here's where it starts. At 0. 0, 0. Do you agree with that? Mm-hmm. My x-intercept is 0, my y-intercept is 0. No distance, no height. How far is it kicked? Where is that on this graph?
45.
It's right here, right?
Yes.
Do you agree? This is where it hit the ground. Okay? Is that number looking at me right there on my equation?
Basically.
What is it?
46.
Very good. It's 46. Didn't even have to do any work again. Do you see what I'm saying? Okay. So let me show you, I'm gonna show you how to do this on your calculator, just in case it's not written in intercept form and I wanna work it on my calculator. So I'm gonna go second and calculate. Does anybody know what the X-intercepts are called in this list of things?
Zeros?
Yes, they are called zeros. X-intercepts, zeros, answers, solutions, and roots. Those are all the same things, okay? So I'm gonna choose number 2. Now, here, look, he wants a bound. It's over here, this is the one that I want to know. He wants a left bound. If I'm right here on my curve, a left bound is above this number. Do you agree? Okay, so I'm gonna get to the left of it. I'm gonna go down here by it a little bit. Okay, so I'm at a left bound, so I press enter. He shoots up that arrow. Now what's he want? A right bound. Where's a right bound gonna be?
Lower?
Below it. It's gonna be below it, okay? Now y'all look, this is why I know my calculator's a guy, right? He needs boundaries, okay? He needs boundaries. So I'm gonna go below it. Am I below it?
Yes.
You see my y is negative? I know I'm below it. So there he is. I gave him some boundaries. Now, there's another guy thing. What's he want to do? Play a game? You want to play a game? No, I don't. Press enter. And there's my answer, 46, just like you said. Is everybody good? Y'all know how to do that?
Yes.
Have you ever done that before? Yes? Okay, good deal. All right, the next thing I want to know is my maximum height. Where is the maximum height going to happen on this parabola?
At the top.
At the vertex, okay? Do I know how to use these two numbers right here and find the vertex?
Yes.
I add them together, divide by 2, and that gives you the x-coordinate of the vertex. Do you agree with me? Okay, so I'm going to find it on my calculator. Watch this. I'm going to go second and calculate. What's it called?
The maximum?
A maximum. When your parabola opens down, your vertex is a maximum. When your parabola opens up, your vertex is a minimum. Very good. So I'm going to choose number 4. Okay? Look what he's doing again. See, I told you he's all about boundaries. He goes, hey lady, wait a minute. And the reason is because sometimes we'll be graphing curves like this. Okay? And this curve has, it looks like it has 2 maximums. They're called relative maxes. Okay? But that's why he's saying I need a boundary. So he always asks for that. So I want a left bound. So I'm going to go, my spider's way down here. I'm running him up. I'm going to put him on the left. Now, do I have to zero in on where I put him? No, people just get to the left. Stay away from the top of that thing. On these pixelated calculators like this one is, I can see a flat point. Okay, and you'll always see a flat point. On the new calculators, they're not as pixelated, so it's a little bit harder. So stay away from the vertex. I press enter, he shoots a boundary, and now he says, hey lady, give me a right bound. So I go to the right. Do I have to go to the right just as far as I was to the left? No. People, he doesn't care. He just said, get to the right. Okay, I can go way down here if I want to. All right, so I shoot another boundary. No, I don't really want to guess, Mr. Calculator. So there is my maximum. Okay, so let's talk about this. This didn't happen last period. Okay, look at that number right there. Tell me what that number really is.
23.
23. It's
Yeah.
23, people.
Mine says 23.
Yours says 23. Do you know what sometimes they'll say? 23.000000001. People, guess what that is?
23.
23. 23. Okay? Did he get close?
Yes.
People, he got close enough for NASA to be okay with that. All right? He is fine. So it's 23. My y value is what? 13.75? Are you with me? Okay, so here's my question. Which one of those is the maximum height?
23.
Yeah.
Oh. Yeah. 13.75.
You see what I'm saying? The y value is the vertical distance, and that's the height. Okay? So it's 13.75, and it is yards. Okay? This one's yards also. All right, so I want you to write something down. This is very, very important. You need to know it. Okay? I'm going to start and write it in pink. So here it is. The x value is where the min or max occurs. Or what gives you the min or max. Now, let me explain what I'm talking about when I say this. This one is obviously what we were just talking about. The x value, where does this min or max occur? 23 yards out from where he kicked the ball. He reached his maximum height of 13.75 yards. Do you understand? Okay, so what about this one? What gives you the min or max? Let's say that we had a business and we make bicycles. We want to maximize our profits. Do you agree? Let's say that you graphed the equation that represented your profits, and the vertex point of that was 250, 160,000. Okay? That says that we need to make 250 bicycles in order to maximize my profit to 160,000. Do you understand? So the x value gives you whatever you need to make the min or max. The y value, so write this down, the y value is the min or max. Is that important?
Yes.
Yes, because if you put the x value right here, then you would be wrong. Okay? All right, very important. This right here is very important. Okay, anybody got a question? Okay, so we got one more thing to do. What time do we ring?
25.
Okay, so I got 10 minutes. I'm about the same place I was last class period. Okay, so here we go. We are going to, before we work a problem, I need to teach you a skill. Okay? I'm going to teach you a skill like this. X minus 5 quantity squared. Should you know how to do this?
Yes.
You go x minus 5 times x minus 5 and you fool it out. Do you agree? I'm going to teach you how to do this, and eventually you'll get down to you can do it in less than 5 seconds. But at first, I'm going to give you 10 seconds. Okay? I'm going to give you 10 seconds. So here we go. How to square a binomial. What does bi mean? 2. 2 terms. I'm squaring it. Okay? Very, very important, people. Very, very important. Squaring binomials is fixing to be a little small piece of a problem. You know how it messes your problem up if you have to pick up a calculator and go 1 plus 5 is 6? Wouldn't that like skew you away from your problem? You'd lose the flow of it? All right, so we don't want this to make us lose our flow. We want to understand what keeps going on and mess the process up. So number 1, 4 things you have to do. You have to square the first. You can do that, can't you? All right? Number 2, you have to keep the sign. Number 3, you're going to twice their product. I'm going to put the word rainbow out here because when you first start doing this, it's best to draw the rainbow. After you've done it for a little while, you won't need the rainbow anymore. Okay? But at first, to keep you from making careless mistakes, I suggest you draw the rainbow. And the last one, plus square the last. Okay. Are you ready? Yes?
Yeah, sure.
Okay, so here we go. I'm going to square this binomial, okay? I'm going to call out the directions and you tell me the answers, all right? So, square the first.
Squared.
Keep the sign. Minus. Twice their product. Their product is what you get when you multiply them. What's 5 times x? Notice I'm not dealing with any kind of signs. I've already taken care of the signs. I don't worry about them anymore, okay? What is twice 5x? 10x. Plus, square the last. Boom. There you go. That's the answer. Okay? Now I'm going to show you why we double this product right here. So look right here. X minus 5 times x minus 5. So x times x, that's squaring the first. Okay? The inners will give you a negative 5x, and the outers will give you a negative 5x. How many 5x's do you have? 2. That's why you twice their product. Okay? And then last times last, y'all, anytime you multiply something by itself, it will always be positive. Okay? And then you're squaring the last. Are you with me?
Yes.
Okay, so I'm going to give you 10 seconds. 10 seconds. Okay? So I'll give you 1 second to finish writing it down. X plus 9, quantity squared. You have 10 seconds to square it. You're following these rules. Okay, you got it? So square the first.
X squared
Keep the sign.
plus
Their product is 9x, twice the product.
18x,
Plus square the last.
81.
Perfect. Is everybody okay? Y'all like this?
Yeah.
All right, here's another one. I'm going to make this one more difficult. Okay?
Oh, great.
So are you ready? How many seconds will you have?
18.
10. 10 seconds. X minus 6, quantity squared. X minus 6, quantity squared. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, was the problem any harder?
No.
What made it more difficult?
Negative.
I started counting, and what happened? Your heart rate went up, you started to sweat. You're like, oh my gosh, oh my gosh, oh my gosh. Guys, that's how you learn how to perform under pressure, is by pressuring yourself. Okay? So, tell me what you got for your answer.
X squared minus 12x was 36.
Anybody got a question? Okay, here we go again. Are you ready? Ten, 9, 8, 7, 6, 5, 4, 3, 2, and 1. What's your answer?
X squared plus 14x plus 49.
Perfect. Okay? Do you agree that you can get down to 5 seconds apiece? You agree?
It's plus 14.
Sorry. Sorry about that. Okay, I'm going to make this one a little more difficult. Obviously, I can't make it more difficult by counting because I've been counting. Okay? So here we go.
Oh. Uh-oh.
Whoa, whoa.
Hold on.
10,
Wait.
9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, so some of the kids said, oh, Miss Davis, I can't do this one. And I said, why? And they said, because it looks different. I said, people, just because it looks different, do you change the rules of the game?
No.
No, people, you keep doing the same thing. Square the first.
25
Keep the sign.
minus
Their product is 30y. What's twice that?
60y.
Okay? Do you remember what I said about writing the rainbow at first? Okay, it's best. Plus, square the last.
36y.
36 what?
Y?
Y what?
Square.
Okay, I did it. I just put it in different order.
Y?
That's okay.
Y is
It's
y
okay.
squared.
All right. Why? Because you got to square this whole thing.
Oh,
That means
yeah,
you square
yeah.
the 6 and the y. One more, okay, and the bell's about to ring. So here we go. 2x minus 9y quantity squared. 2x minus 9y quantity squared. Is that what y'all got?
Yes. Oh,
Got to square the 4 and the x. Got to square the 9 and the y. Twice the product. Stop. This is why I taught it to you. Because you have problems on your worksheet that say write in standard form and they gave you to them in Vertex form. What are you going to do first? Square this binomial. Boom. Distribute the 4